Lesson 1-3, Solving Equations. Objective, translate verbal expressions into algebraic expressions and equations and vice versa. Solve equations using the properties of equality. Let's take a look at translating a verbal expression to an algebraic expression. Let's look for key words like more, which means addition, 4 times multiplication, and cube is a power to the third power, and this is what it translates to. Quotient, and we're being told we're going to have a quotient, and it's going to right now describe the numerator, 5 less than a number, which is n minus 5, and it's going to describe the denominator. So the quotient is our heads up as to that we're working with a fraction. Let's go ahead and translate the cube of a number. So I'll say x cubed. Increased is plus 4 times the number. The next one says 3 times, so 3 times, and now it's going to tell us we're going to times by a difference, which means I need parentheses to go ahead and write my difference, and my difference will be y minus 8. Let's take a look at the reverse. Let's see if we can write this. So since this is a multiplication problem, we can say a product in a number, and is a good indicator for equality, and then 72. Sum of the two items is the sign, the equality sign, and then 91. So let's go ahead and write these. This is going to be the difference of a number and 5 is -2. Over here we can say twice a number is the square of a number minus 4. So minus is another indicator of subtraction. Properties of equality. There are 4 of them. Reflexive is when something is equal to itself. So in this case, b plus 12 is equal to b plus 12. Symmetric is when two things are equal to each other, they're equal to each other in reverse. Notice that these two are equal to each other, and they're also equal to each other in reverse. Transitive is when two things are equal to the same thing, they must be equal to each other. And so these two expressions are both equal to 48, so these two expressions must be equal to each other. And substitution is about replacing. So we can take an expression and replace it, and then have a new expression here. We're going to name the property illustrated by each statement. I want you to notice that we have these expressions that are equal to the same thing. When they're equal to the same thing and they equal each other, that's called the transitive property. Right here, I see that these two, this and this, are almost the same. And I see that 62 and 62 are the same. The only thing that seems to be different is there is no h anymore, and that's because there's been a substitution here. Now, this problem right here, I'm looking and I'm seeing this is in the front and now it's in the back. This is in the back and now it's in the front. This reversing is the commutative property. Okay, and addition and subtraction properties are what we use when we're trying to solve. If you add the same thing to both sides or subtract the same thing, then we call this subtraction property. And this is what we do when we try to solve for x. To undo subtraction, we add to the same thing to both sides. Or if we're wanting to undo addition, we're subtracting the same thing. This happens for multiplication. We can multiply both sides by the same thing or divide both sides by the same thing. And we do this to solve equations. So to undo division, we multiply by both sides. If you want to undo multiplication, you're going to divide both sides here. All right, let's take a look at how we use this. This is the equation, and when we add the same thing to both sides, then we're going to get the identity for addition, which is 0, and then this will be n, and then we get our answer here. If we want to undo subtraction, we're going to be, that's the check. When we want to undo multiplication, we can multiply by the reciprocal, and this is going to give us our identity for multiplication, which is 1. and then we're going to find the answer to the other side. Okay, in a multi-step equation, we might have to use the distributive property, and then we get like terms, and then we undo our addition, and then we undo our multiplication, and we get our answer. Pause and do this problem. Stop the screencast. And here's the answer. Let's look at solving for x. In other words, we want to get x by itself. Now, to get x by itself, we have to undo addition first. So we're going to subtract 3y on both sides. And this is going to create a 0, which is the identity for addition. And then I'm going to write this. I can either write 8 minus 3y, or I'm going to write minus 3y plus 8. It doesn't really matter. Now I'm going to undo multiplication. And then I'm going to get x is equal to negative 3y plus 8 in my numerator, all divided by 2. You can leave it that way, or you can write it as 2 fractions, like this. Now let's go ahead and solve for x. To solve for x, we're going to undo our addition, so we're going to subtract 8 on both sides. And I'm going to get y minus 8 is equal to 3x. Now I want to divide both sides by 3. And I'm going to get y minus 8 divided by 3 is equal to x. And we can write it as 2 different fractions as well. Either answer is okay. Pause and see what you can do. And here's the answer. Pause and see if you can solve for 2x minus 3. And here's the answer. I want you to notice that I didn't solve for x. I subtracted 9 on both sides on purpose so that I could get this expression 2x minus 3, and I got negative 12. Now, the other way you can do it is to take 2x plus 6 equals negative 3, subtract 6 on both sides. 2x is equal to negative 9, x is equal to negative 9 halves. And then you could take negative 9 halves and put it into this expression, negative 9 over 2 minus 3, and that'll be negative 9 minus 3, negative 12. Now, what I just did in this red is a technique that could really save you a lot of time when you're taking the SAT, because this is a typical SAT question. Pause and see if you can find the error, and here's the answer.